Good morning. This is Dr. Oz. In this video, I would like to show you how to do shortest path algorithms. And to do that, what I would like to do is first of all, go to our class Blackboard and scroll down and you will see here 1.5 shortest path. And underneath here, you will see a PowerPoint. So let me just download that first and launch that PowerPoint. Perfect. So, shortest path algorithm, why do we care about this? Because it will help us to find the least cost route, and the cost doesn't have to be money. It can be distance, it can be time, money, or risk. So, for example, here, the shortest path to reach from point A to point C would be go to A to D, which will cost us one amount. It can be again $1, 1 mile, 1 kilometer, 1 hour, and so on. And then D from node D to E and E to C. So you can see if you go over the edges of from AD, DE, and EC, that will be the cheapest route to complete this path. And there are different applications in business. Logistics is one, how to deliver goods using different modes of transportation and different routes. Project planning is another example. How can I finish the project on time without any delays? And then customer service also, how can I resolve my issue with shortest call escalation path? So let's take a look at an example. So let's say I would like to do from A to F, start from node A and go to all the way to the F. And here are the costs associated with each edge, A to B, and so on and so forth. These are the costs, and see what's the shortest path to do this problem. So let me just take a screenshot of this so that we can use this information again and again. Perfect. So now what I would like to do is go through Dijkstra's algorithm, which is one of the best algorithm to find the best solution. So let's do that. So Dijkstra's algorithm, if the calls are non-negative, which in business settings, most of the algorithms, if not all, problems are calls are non-negative. And the idea here is that updating every single node for best known cost, okay, by relaxing the its neighbors. And we track of, you can see best known distance and previous location. So when we first start this model, this algorithm, the starting point, which is A in this case, start with zero cost, and everything else would start with infinite, like very, very big cost. That means we want to go to A first to encourage that we have lowest cost possible there. And you can see our visited nodes here is empty because so far we haven't visited any nodes yet. So step number one, we pick A. Why? Because again, A is the lowest cost out of these six nodes. Now we need to update, relax the neighbors, and update the neighbors. So from A, where are the places that I can go to? Let's go back to our screenshot. So from A, we can go to B. From A, we can go to C. And costs associated with those edges are 4 and 2. Let's update them B and C accordingly. So B is 4 plus 4, C is plus 2y. Again, these costs associated with them. And A itself has zero cost, so that's why 0. 0 plus 4. So for B, the new number is instead of infinity, we'll update it to 4. And C 0 is A again, cost of A, and plus 2 additional from A to C. And that's 2, so we update this C to 2. And you can see D, E, and F still infinite cost because there is no connection directly from A to those three nodes. And we keep track of also previous B. So if we decide to go this node this way, it means that our previous node is A, so A to B. Same thing for C, A to C. Okay. So step number two, we will pick the again lowest cost when we look at these options. C is the lowest cost with 2. So our next visited node, uh, or permanent node, I should say, is C. Not necessarily the next visited node, it's the next picked permanent node. Permanent node is that the one that's the cheapest cost that's selected. So now if you look at the table again, from C, there's only one node that I can go directly to, which is D. C to D, extra cost is 8. So now, since we picked C, we can update the neighbor D by cost of C, total cost of C, which is 2, plus additional cost, which is the edge from C to D is 8. 2 plus 8 is 10. And previous for D is C, right? Because we get this number from C. And so far, if we keep track of visited, again, previous step it was only A. Now since we picked C, visited nodes are A and C. And D, again, we updated the D to 10. It was infinity, now it's 10. As you can see, A was 0 and it's permanent now. B is 4 and still 4 because nothing changed to B in step number 2. And C was permanent as well, so it doesn't change 2 to 2 because we chose C here. And D was infinity, now it's 10. E and F still infinity. So now if you look at it, A is visited, C is visited, so the lowest cost is B. So we will pick B in step number 3. So we can see step B is the next step, which the cost is 4 because again, that's the cost right here. And now we update neighbor. So from B, where can we go directly? B to D plus 5 cost and B to E 3 plus 3 cost. So D and E updated. So D previously was, if you remember, 10. Now I'm comparing the 10, minimum of 10, which is the previous cost, and the B, total cost of B, which is 4. And if I go from B to D, the cost is 5 additional cost. So 4 plus 5 is 9. So we're comparing 10 versus 9. Okay, 9 is lower because we are trying to minimize the cost. So now that means I need to update previous value for D. Previous value for D is B because that's the cheapest way to get to D so far. And E, it was previously infinity cost, if you remember, right here. Uh, and if we go from B to E, current cost of B is 4, and E is 3 additional costs. 4 plus 3 is 7. So that's cheaper than infinity, obviously. So previous E should be updated to B. So I need to go to B to be able to go to E. And so far what we visited was A, C, and B. So since we updated those distances, now you can see A is visited. So B is visited, C is visited. So we are looking at D versus E versus F, and cheapest cost is E, which is 7. So now step number 4, we pick E with cost of 7, and we again update neighbors. From E, we can only go to F, so F should be updated by 2 additional costs on this edge. So cost of E is 7 plus 2 additional costs, so 9 costs for F, and previous of F is E, because again, first go to E, then F in this case. So now E to D, we say that 7 plus 2, 9, which ties with current cost of D equals to 9. You remember D was 9 here. And if we go from E to D, that will be also cost of E is 7 And actually, okay. Okay, so but basically, uh, F and D have the exact same cost because again, if you look at the visited ones, we pick E in this step A, C, B, E. So we have D left and F left, and they are the same cost. So I can choose either one. That's perfectly fine. In general, if this happens, I choose alphabetically lower one. So let's pick D. So we need to update the neighbors again for D. So if you look at the D, I can go to E with 2 additional costs and F with 6 additional costs. Uh, but again, I don't care about E anymore because I already reach E is already permanent. So then I will only update F. So currently, previous step F was 9, and now 9 versus the cost of D9, which is additional also edge cost of 6, 15. So 9 is cheaper. So no change. I don't need to update anything. And so far we visited everything but F. And the distance is nothing updated because again F did not change. That means that F will be very end. So now what I can do is create the final path by going to reverse order. So what do I mean by that? Last one is F. We did last one F because it's left at the end. Right before that, to get the F, we need to look at the previous of F, which is D right here, right? So that's the one that we got at the very end, step number 5. And then before that, step number 4, we got, so we have D here, we have, so how did we get to the F, right? That's the important question. Um, so F, we got it through E. The previous of F is E. So F, E, and then previous of E is B right here. So we put B. So previous of B is, let's see, previous of B is, how did we get to B? So basically, um, I'm trying to find the previous of B, which I can't see it yet. Okay, so previous of B, we got it from A directly, right? Yes. Previous of B is A, previous of C is A as well. So that's why I put B here, and the previous of B is A. So again, C doesn't matter because that's not really part of our final path, um, because it's just A to C and then there's no continuum. So now we can go reverse order if you want to. A from A to B, B to E, and then E to F. So total cost is 9. Okay, so that's it for this video. Until next video, enjoy business analytics.